In this problem, we're gonna find the distance between two moving people on two different paths. So the first one is moving on this line given by this equation y equals -3, and the second one is moving on this parabola given by x squared plus x plus 1. The two moving persons are always on the same vertical line. So when you draw the vertical line, they are always in this vertical line. So our interest in this problem is to find the distance between the two. So at every moment, this is the distance between the two. Okay, when they are here, this is the distance. Okay, and we see that the distance is smallest when they are at these points, one in here and one in here. Okay, and the distance increases as we move further away from this point here. So to find the expression for the distance, we know that given any 2 points, let's say point A, which has coordinate x1, y1, and B that has coordinate x2, y2, the distance between A and B, let's say the distance between A, B is given by this formula. It's going to be x1 minus x2 squared plus y1 minus y2 squared. So in our problem, we need to find what's x1, y1 for this first person, and what's x2, y2 for this second person. And from there, we can use this formula to find the distance. Given that they are always on the same vertical line, that means they have the same x. Okay, so this is a great idea that will help us. So for this person, okay, the x is changing, so x here, but the y is gonna be the same, -3. The same thing for this person here. It has the same x, but the y is given by x squared plus x plus 1. So now we have 2 points, let's call them 2 points, A and B, as we did here, and let's find the distance. So the distance is, so x minus x squared, which is 0 obviously, and the second one is x squared plus x plus 1 minus -3, it's plus 3 squared. Okay, so now we have 0 plus x squared plus x plus 4 squared. This gives us x squared plus x plus 4 squared. Okay, so this is the expression for the distance between the two. But we can simplify this one. Okay, we note that this expression inside the square, this square here, is x squared plus x plus 4. Okay, and if we compute, let's call it A, if we compute delta for this A, we get 1 squared minus 4 times 4, which is 1 minus 16, it's minus 15. It's less than 0. It's minus 15, it's less than 0. That means this one is always positive. This quantity is always positive. Therefore, we can have the absolute value x squared plus x plus 4, but we will take it out because this is always positive. So we have x squared plus x plus 4. I did the absolute value because when you have something inside the square root that's squared, it's equal to the absolute value of x. Unless x is positive, it's equal to x. Like we did in this case, this quantity is positive. That's why I had to take the square root. The absolute value, pardon me, the absolute value from this expression. That means the expression for the distance is x squared plus x plus 4. Note here, when x is 0, okay, the distance is 4. And we can check it here. So when x is 0, our person here is at the point 0 minus 3, and this one is at this point 0 1. Okay, and clearly you see the distance between the 0 1 and 0 minus 3 is 4. Okay, and this agrees with the expression that we get here for the distance. Another thing is that we can graph this one, okay, by just looking or just seeing that x squared plus x plus 1 and x squared plus x plus 4 is just this one shifted 3 units. So this one is 1, 2, 3. It's the same graph shifted 3 units. Okay, we can graph it. I don't have space here because of the staple logo. So this tells us that this is the expression and the distance for the two. Another thing is that if we have a different case, a different scenario, when these two guys are not moving in such a way that this line is always, they are always on this vertical line. If we assume that they are in different lines, maybe this one is moving here and this one is moving on this one. Okay, this would give us a different equation. Okay, and we can do the same thing to study it, but our aim is to try to see how to apply this distance formula to get a result for the distance between the two. Okay, we can do more. So in animation, we assume that we have a ship that's moving here, okay, and another one that's moving here. Okay, we want to see when the two are close together. We want to find the distance where they are the closest. Okay, so we're gonna see that we have some kind of waiting time. Sometimes if you are speeding up, you are in advance of this one, you have to stop here and wait, and that time can be computed, but that's another problem that requires more calculus issues. We are not going to deal with that. The most important thing is to find the distance between these two and graph it and see what it means. Thank you.